Hey, so I forgot to put it on the board as please head out, but yeah, the resource page is back out there. Back there. That's all of the resource pages for this chapter. So don't lose it. That's all the resource pages for this chapter. Please don't lose it. I beg of you. Oh, and you can't see because my screen's frozen. There you go. Sorry. Homework written down, please. You guys know that the organization check is coming soon, so plan book is part of that. If you turned in your math journal yesterday, it's on the back table. If you turned in your math journal yesterday, it is now on the back table. What's up? Problems 29 to 30. It's also always right there, closer to you. What's up? In like global cultures room, we can ask her on the form. Hopefully it pops up. Like somebody will realize it's not theirs. They probably picked it up from That's my hope. I have a couple of things. You can never find it. I have a couple of Just take notes on paper. We'll get you taken care of. Okay? I promise you we'll get you taken care of. Don't worry about having the toolkit today. We're using the resource pages anyways. But, right, I don't think anyone did. I mean, we all have a toolkit. Who wants to steal one of those? You really want an extra toolkit? Yeah. All right. So, we are working on 4.2.1 today, so please join me in your book on 4.2.1. And I'm really not feeling the greatest today. I'm good at putting on a face. Like, I'm good at acting, but I'm not great at projecting long term when I don't feel well. It just makes me feel kind of ill. So I'm going to see a doctor this afternoon and getting that taken care of. I don't have a temperature, so don't yell at me for like being at school. But please don't make me talk loudly today. It makes me feel worse when I have to talk really loudly. So I'm going to start setting us up for the lesson. I'm going to read our intro, so if we can quietly listen, that would be great. Moving Deer, what's up? Oh, so I'm going to talk about that too. So I'm going to post the answers on Schoology. So there will be a post up, and I started this because I didn't want to post it before we talked about it. I was going to say, make sure you're filling your homework feedback form. Homework 3.1.1 is what Math 7 did, and then I'm going to post homework 4.1.2. Yes, which was last night. All I'm going to post there is the answers. Say like 16 is this, 17 is this. Then, and I'll actually probably put two different posts. I'll make this one say like Math 7, and I'll make the other one say, Accelerated 7. And we may just split Schoology pages now that we're going to start to use Schoology a bit more. We'll see how this works. I like trying to keep it together because we are working in the same textbook. But we'll see how complicated this gets. Probably Thursday or Friday, we're going to come all together with all the homeworks we've done all week and take any questions you guys have. Because we're not doing any assessments before then. We're not doing anything else. And some of you just need a little bit more time. Like we didn't get to it last night. So I'm not going to require you to get it done today. But at some point, AO extensions, whatever, get on and check the answers to homework. If you have issues, you can then reply to this. So just like on Facebook or Instagram or whatever else, you can reply and ask questions, and then you can reply to your friends. So let's say Oliver gets on there and he's like, hey, problem 17, I got a different answer. And then Ava gets on and she's like, oh yeah, I got that first. Here's what you did. Try that. And I'd probably get Ava a piece of candy for helping out a friend. So extrinsic motivation, extrinsic meaning on the outside, if you help your peers, like genuinely help your peers figure stuff out, there will probably be some incentive there for you. So not just like, oh bro, try it again. Or like you gotta actually like help them out. Okay? So that will get posted here today. So grocery stores often advertise special prices for fruits and vegetables that are in season. Like right now we got all the fall fruits and vegetables. So you might see a sign that says special today, buy 2 pounds of apples for $1.29. $1.29. Sorry, Mr. Michael. How would you use that information to predict how much you would need to pay if you wanted to buy 6 pounds? Or what about just 1? The way the cost of apples grows or shrinks allows you to use a variety of different strategies to predict and estimate prices for different amounts of apples. So in this section, we will explore different kinds of growth patterns, and we will use those patterns to develop strategies for making predictions and deciding if things are reasonable. Do not blindly trust an answer. Think through, does this make sense? Does the answer that I have work in the situation, or is it nonsensical? Like you're talking about like time and you get, I don't know, an answer in the millions of years or something, probably not normal. If you're talking about distance and you get a negative answer, well, distances can't be negative. Like, think through, does this make sense? All right, so how are entries in the table related? Can I double the values? Does that work? And what patterns can I see in the graph? So let's check this out. 421. I'll go ahead and read it for you guys to save you time. I think the reading as your groups takes up some of your time. So 5 years ago, Gustavo's grandmother put some money in a college savings account for him on his birthday. The account pays simple interest. Don't worry about compound interest. I don't think we really get to it this year, but simple interest is the basic kind of interest that banks use. So the account pays simple interest, and now, after 5 years, the account is worth $500. So Gustavo predicts that if he does not deposit or withdraw any money, then another 5 years from now, it'll be worth $1,000, right? If it took 5 years to get to 500, then it'll take 5 years to get to 1,000, is Gustavo's reasoning. So how do you think Gustavo made his prediction, and do you think that's accurate? If you don't think it's accurate, how would you make a prediction? What information do you need to know? What issues are like? So just discuss this with your team. What do you think about Gustavo's prediction?
Like how much money you have to spend, that makes how much money you get. If you have a lot of money, you get a lot more interest.
Anyone confident enough to talk about this class? Alex? So what do you like? What was your group saying about? Well, first off, is this prediction right?
Most likely.
Most likely, okay. So then explain.
Since it says that after 5 years we counted for 500, what we did was divide 500 by 5 and got 100.
So you're thinking he made $100 every year.
Yes.
So how much did he start with?
$100.
But then if he made $100 every year, wouldn't he have $600 a year? How do I put $0 in the bank and make money? Well, I mean, you can open an account. Some places will let you just open an account, but most of the time you need money. So wait. So how does interest work? Does anyone understand how interest works?
I think I do. Isn't it like if you have like $1,000, they'll give you more interest and give like $500. So like based on how much money you have in
It
your account,
depends. That's the
they
hard
give you a
thing.
certain amount back and put it into your account for putting it in their bank.
So let's say Will wants to buy, just because he's here and easy, Will wants to buy a new video game or something. And he doesn't have the money right now, but he knows I have the money. So he goes, Mr. Hudson. He goes, Mr. Hudson, can I borrow $20? And this happened. We were in Chicago. We won't be going to Chicago anymore. We were in the CN Tower. And a student comes to me and wants to buy a Lego model of the CN Tower, which I was all about. But he had run through his money very quickly. And we warn you guys when you go on these trips, don't use up all your money like halfway through the trip. So I loan him $20, but I tell him, you're going to have to pay me interest. Okay, so you might want to be aware of what is interest. So what does that mean? If I loan you $20 and I tell you you're going to have to pay me back with interest, what does that mean?
That means I have to pay you back, in total the amount.
Plus,
Ooh, plus even more. Moving your hands through the ceiling.
Some banks have interest of 10%. So, our
Most don't. Sorry, interest rates suck right now. Just to let you guys know. Interest rates are on the floor. Like, you could buy a house, and your interest rate is 4%. That's it. That's great. That's wonderful. That's why I bought a house, because interest rates are really low. Which means you don't have, so if 4% of that 20, let's play this out. Let's be really simple. So let's say banks have 4%. Let's say I'm going to be that bank at 4%. I loan Will that $20. What would be 4% of $1? 4 cents, right? 4%, 0.04 of $1 is 4 cents. So of $10, it'd be 4D cents. So for $20, what's 4% of that? 80 cents. Right? So now you have to know how often does that get compounded. So let's say that, and this is where simple interest is simple as opposed to compound interest. Let's say Will owes me 4% interest every day. So day one, if he paid me back a day after, what would he have to pay me? $20.04. Not 4. It's 4% of the whole money he borrowed. 80 cents, right? Because that now that's a really short interest term. A day, that's like killer. That would not be good. Well, it's good for me. But so Will doesn't have $20.80 that day. So I'm like, okay, that's fine. Keep it. Interest keeps going. What would he owe me after 2 days? Well, $21.60, right? And after 3 days, plus $22.40, right? 80, 16, 24, $2.40. So the longer Will keeps my money, the more he owes me. So do you want to keep my money?
Yeah.
You're going to owe me. So the problem is, one, you have to be able to pay it back, right? If you borrow money. And the second thing is, the longer you keep it, the more you owe them. Now, this can flip on the other side, though. If you have all the money, and you go to the bank, and you're like, hey, bank, want some money? The bank's like, of course we want some money. It's a bank. We want all the money. So the bank takes your money. And they do not just keep it. They don't, like, lock it up in a safe, and they're like, this is Will's money. They invest it. They put it into other companies. They give it to other people. They buy my house with your money. Not joking. But then you go to the bank and you say, hey, I want my money back. And because you've had it for so long, I want my money and some extra since you got to play with my money while you had it. And that's interest on the consumer side. And this also works if you want to make a college fund, or anyone ever heard of a certificate of deposit? Any grandparents or anybody buy it? Do you have a CD? Yeah, so certificate of deposits are, I give my money to the bank for a set amount of time, and I can't get to it. So that's like I go to the bank and I say, I've got $1,000 extra just sitting around. Would you like it for 10 years? But in 10 years, I want back $1,300 as opposed to just $1,000 I gave you. You make this agreement with the bank, and you sign a piece of paper, and you take home a piece of paper, they keep your money. 10 years later, you can get your money back. If you want it sooner, you pay a penalty. You'll still make a bit of money, but you pay a penalty. You don't get all the money that you would have wanted. So if this is going to work out for Gustavo, he has to start with some amount of money in the bank. Because you can't start with 0 and make money. You would make any percent of 0 is 0. I know I've got some people not paying attention to me, so if you've zoned out, please come back. Moving here.
Would it be monthly interest or
It depends. It depends on the agreement. Now, here's where simple and compound are different, because I know there's some brains turning and you're thinking, simple interest only charges interest on what you borrow. Compound interest screws you over even more. So let's play out Will's situation with compound interest, right? I loan him $20. Day one, he now owes me $20.80. When I go to calculate day 2, I would then, and you don't have to learn compound interest, I'm just showing you why this is so terrible. our interest rate's 4%, right? But now day 2, it's not 4% of the $20. It's 4% of everything he owes me.
Oh.
By day 3, calculating day 4, it's 4%, 0.4 of everything he owes me. But now this would be even bigger because these values would have gotten bigger faster. Compound interest will charge you more money more quickly any way they can. Of course, as soon as I walk back here. Good work, dude. All right, so that's compound interest. Do not agree to a compound interest account. It is not good. You will owe lots of money. Now, if you're investing the money and they offer you compound interest, heck yeah, snatch that up. So last week, Gustavo got his bank statement. And it told him that in 5 years from what he was looking at, his balance was going to be $600. So look at that resource page you have. Grab that resource page. What we now see is a graph relative to time. Make some observations about the situation that you've been told, the graph that you see, and we're going to come back and talk about this in about 2 or 3 minutes. Talk with your team. What do you now realize? What could you say? What inferences could you make? And I'm going to go ahead and push you. How much money will be in this account 20 years after this time?
I don't know.
Because you haven't had any time to think yet.
That's because I think he didn't know how. I don't know if he knew how much. That really messed up.
Depends when the account started. So I was waiting for somebody to say that. So I love what Alex just said. Well, why would you wait 20 years when you be out of college? A lot of grandparents will, when a child is born, invest some money in the bank.
I've been getting money from my grandfather since he's long time.
Because if your grandparent passes away, that money is still there, and they normally have something like in the writing or whatever. Your parents can access it or you can access it. So let's say this started day you were born, day Gustavo was born. Now, he obviously wouldn't be thinking about financing at 5 years of age, but if we play this out, 20 years from when you're born, you'll be in college. You got to pay rent, you got to pay for your textbooks, you got a lot of like bills coming at you that you need some finances for. So if we wait 20 years, anyone have a prediction? Ian? How much money, if he goes to the bank to get it out at 20 years, how much will be there? How do you figure?
Because 400 and then every 5 years is 100 more.
So every 5 years, we're getting 100 more is what you're saying. Which means that every year, if we try to break this down, so our rate was $100 for 5 years. And we can break that down to look at the 1 year by dividing by a giant 1. And I heard a few groups say this, $20 a year. So I can really just say, well, 20 years times the $20, how much money does he make? He makes $400 on top of his initial $400. Does this make sense? Wunderbar. So, moving on. My book is in the wrong place. You did my what? Oh, that's marking math 7. I'm not putting it up there. It's up on the TV now. That's my normal. If there's space that I can write on just this page, I can just slide it up on the TV. So because we're the accelerated setting class, this is one of those lessons where we're probably going to fly through a little bit faster. When Gustavo looks at his bank statement, this is what he sees. We've already filled all this in essentially, right? Because what would he have had 1 year after investment? 420. What would he have like 6 years after investment? 520. We know that the change in each of them is 20 years. So $20 per year. We are looking at this essentially. We're seeing that this is continuing to increase by 20 years every time this increases by 1, which tells me that's not just my rate. Who knows the specific name for a rate where it's per 1? A unit rate. So our unit rate that we would then say here, I'm actually just going to leave that here. Since this is plus 20 and this is only plus 1, that means our unit rate is 20. So please jot that somewhere, or at least have $20 per year. Know that that is what we're dealing with right here. So the bank predicted $600. Can we trust that? Yeah, if this stays the same, right? If we keep getting $20 per year, that's if this is simple interest, which we were told it is. Now, if this was compound, that estimate would be wrong. We would actually get more money, which would be great. That's why banks don't often use compound interest when it's your investment. They use it when it's their money. So we make this graph, and we have it in Desmos. Yeah, let's move on to 425. I think we're pretty good on that stuff. Check out 425 on your own. I'm going to let you guys process this situation for a few minutes, and then we'll come back to it. What it really comes down to is, can you fill in the table? So keep working through the problem. You want to copy that table onto your paper, just really quickly. You don't have to make it look real nice. Can you fill in the table? By the way, a rate is any statement that involves the word per. So if you have cookies per kid, treats per dog, cups per recipe, pepperonis per slice, anything with per is a rate. Anything where it's per one of something is a unit rate, hence 1 unit rate. We should use some cards, probably, I guess. We don't use cards anymore, though. Piper, what do you think? Is that estimate of $54 correct?
I am not done.
You're not done? Can you help me work through it?
I'm a little unfortunate. I can't finish that because I'm not real this.
So what do we know? Help me with this. What do we know?
Well, other than the straight up information that we figured out the unit rate.
What is the straight up information? So what do we know?
We know that it's $27 for 4 pounds.
$27 for 4 pounds. And you told me we could use this to create a rate. And we know we could either do 27 over 4 or 4 over 27. This would be dollars over pounds.
Wait, I have a quick question.
Hold on. You said we can make a unit rate. Do we need to here? I agree with you, we can. What's it asking?
Strategy. How much per egg?
How many-
Makes sense. How
What is she expecting she wants to buy next time? 8. So if we want to relate this to...
you can just go straight to 8, but I like easier because it makes it easier to just have the basic stuff.
Again,
You can base everything off that.
I just wanted to show the easy way. I get why you went to unit rate first. You're perfect. You're good. This is just one way to visualize the reason they set this up like they did is we can recognize a double, right? If I buy double the amount, I assume I'm going to pay double the amount, which would be 54. Now, Piper, okay, let me come over to Ian. So Ian had a question.
Is that just a typo? Because it goes 0, 1, 2, 3, 4, 5, 6, 8.
Yeah, they just jump 7. They just don't care about 7. You can have 7 on your table if you want.
They don't matter. They're irrelevant.
Okay. So we agree with her on that? We agree with Sonia? I don't know. Probably. So she thinks that 1 pound is $4.75. How? Or sorry, $6.75. How do we get a unit rate?
You get a unit rate by dividing it by
What is it?
dividing the number that you have.
The number. How do I make the choice of what? So I have the. I agree with you that we're going to divide, but I have the choice of this, right? How do I decide? Keep talking.
You would decide by like what the price is that, or no, you would decide by the price over the what you're getting. Price better.
Just decide what you want one of. There's no right or wrong way. You could unit rate either way. We could do either of these. But if this is dollars, and this is pounds, and this is dollars, and this is pounds, this would be pounds per dollar. If I had $1, what could I buy? This, dollars per pound. Which do we want one of? We want 1 pound. We put pound on bottom. So, since we want 1 pound, we use that guy. When we do that division, do we get 6.75?
Yes.
Righteous. What about 0 pounds? $0.
Good morning, Oliver Long, please come to the office. Oliver Long, please come to the office. Thank you.
I think she meant Lang. Yeah. I think she just read it wrong up there. What about 2 pounds? Help me out here. Ooh, 13 what? 13.50. Careful. What about 3 pounds?
20.25.
Does the math work to get to 27? Sweet. 5 pounds? Wow, everyone's talking at the same time and it works out so well. Slash S.
40.50.
Careful. There's a jump in your table. Now, I will tell you, I have seen that happen on a standardized test. Like a state test, I've seen tables jump when it went 1, 1, 1, more than 1. 2 or 3 or 4. Be careful. Okay? Does the table confirm, Sonia, however we're going to say that? Does it work? It all worked out?
Yeah.
It worked. This has a very specific mathematical name. And we see that when we go to graph it. Right? So if I go to graph this, give me your eyes up here if you would. So we said $0 for 0 pounds. You got, actually, I can make this easier by just dragging this over. 1350. Notice that Desmos is going to add these points on for me then, which is sweet about Desmos. 20.25. 5 pounds was 33. What do you notice about every time it adds a point?
It goes down.
It's making a straight line. A proportional relationship. You got to memorize this. Like, you got to know this. This is just one of those things. I'm going to tell you, you got to sink these two things in your memory. A proportional relationship. So please write this on your paper. And if you can remember, you can abbreviate it proportional relationship must satisfy two things. Straight line. Which means it has a constant slope. Yep, because it increases the same thing each time. And the second thing it has to have that throws people off proportional relationship situation must tell you that if you were doing 0 of the one thing, you would need 0 of the other thing. To paint 0 walls, I need 0 paint. To go 0 miles, I need 0 gas. To do 0 math problems, I need 0 paper. To do 0 homework, I need 0 time.
To share 0 cookies, you need 0 friends.
Well, 0 people,
Friends.
right? So be careful. Proportional relationship, straight line through the origin. That will always be proportional relationship. Now, a straight line that is not through the origin. So if we take away this criteria, we take away through the origin, this now, instead of being proportional, is what we call linear. Now, you don't have to know, you don't have to write it right now. But if it seems proportional, like it's changing at the same rate, but like Gustavo's bank account, does it start at the origin? Does grandma have 0 money in it? It starts somewhere else and then increases consistently. So could you please, on the resource page, like in the graph, just write linear relationship?
Wasn't that on our SL though?
Probably. Because that's something that you're supposed to learn.
Did we also have that in our
Probably. They intentionally put things in your homework that you haven't quite been taught yet to push your learning. And that linear relationship, if you want to write down extra on there, Mr. Dunn, in case you don't have enough to write, that's linear because the constant slope. And that slope is that change relationship. It's how much we're changing. Piper, you love to talk so far beyond what your peers understand right now.
I think those are enough to understand.
So then, because Piper brought it up, there is quadratic situations where if you had the graph, hold up, I'm just going to show you really quick so you understand. A quadratic situation, you see it, will look like a giant U, or some people call it a V. That would be quadratic. And then an exponential, and you'll talk about these in science, could be exponential growth, where it gets steeper and steeper and steeper, or exponential decay, where it gets less and less and less. So if somebody tells you, this is an exponential situation. I am 25 feet from the door, let's just say. I traveled half the distance of the door in my first move. In move 2, I travel half the distance of the door. In move 3, I travel half the distance of the door that doesn't exist. Move 4, half the distance. Move 5, half the distance. Move 6, half the distance. Move 7, half of that distance. Move 8, half of that distance. Am I ever going to get there? No. So when we talk about exponential decay, it never actually disappears, but it decays exponentially. So if you order a pizza and you give half of it to your dad, and then you give half of what's left to your mom, then you give half of what's left to your brother, and you give half of what's left to your sister, you give half of that to you will never run out of pizza. And there's actually, you can Google it, we don't have enough time, we might have enough time, but there's actually a problem dealing with infinite cake. Shoot, I shouldn't be going this far into this right now. Hold on. Oh, there's so much more. Fine, because you guys are interested. Alright, hold on. And finite cake. Well, somebody over there turn on the amp. Zach, do you see the big black button on the left side of that amp thing? So I'm going to jump through this because we're not going to watch the whole thing. This is not the correct video.
Yeah, that. His CD hit me. I don't know. Turn it off.
Oh, it might be a super fast. Yeah, so if you ever watch Vsauce, you might be aware of this guy.
As an interesting mathematical property, its volume